Alright guys, so like I said last time, I really want to focus on questions that you have from chapter 1. So hopefully, I know we did some work in class last time, so if there's questions left over from there, and plus if you've had a chance to get into the homework, if you have specific stuff, yeah.
Number 86 on page 126. I don't know if it's 86, but I don't know.
Yeah.
Homeowner free running garden plots.
Oh yeah. So page 126, number 86. So instead of writing this all down, she basically wants 3 adjoining plots to give you a nice little picture. Give you one that's less nice. It's to be 80 square feet in area. And she has 88 feet of material. Fencing material. This is not the rapier sword for fencing like that. So this is kind of a strange, but this is kind of a classic problem, and it's something you probably saw some of in algebra class, but now you're going to see a lot more like this in pre-calculus. They pretty much give you the picture, which is nice. And this is classic, and very often you might have like a river on one side. Does that sound familiar? Or you have a house, and you're going to use the house as one side. You want to build a pen for your pet goat, whatever you got. So the idea is to really work with the picture and then try to translate that into some equations, because there are definitely 2 main ideas. There's an area idea, and there's a not classically perimeter idea, but because you have to build those in too. Well, what can I do with my picture? What is this?
Y.
I love it. I don't know what the hell it is, so it's Y. Or W, or whatever. And there's 2 different ways to go here. You can call each one of these X, or you can call the whole thing X. I don't care. I've already drawn that, so I'm going to do it this way.
X1?
Second?
You want to do this X1 to X2 and X3?
Yeah, it says it's, I think they're all the same. Yeah, in order to make it doesn't say if it's all the same. So let's do this. This whole thing is X. Cool. Good point. So can somebody help me out? There's the first thing you do is try to identify what your variables are. And that should sound very familiar from algebra, right? The good old distance, rate, time problems. So the train's velocity might be X, and the other train's going faster, so it's X plus 20. So here we've determined that the width is X, the width is Y, and the length is X. Can you work with each of these formulas now? What would that formula be? Yeah, xy equals 80. And what would this translate into mathematically? I agree with 2x.
4y.
I like it. So 4y plus 2x equals 88. And now you have a nice classic system of equations problem, right? Or which method can you use to go forward from here? I love it, substitution. Especially when you have a funky one where it's a product of your variables, you don't want to try some kind of weird elimination. Substitution is the one that actually is used more often when your equations are all kinds of different equations. So I would solve this one for x, because you can divide by 2. Get x by itself, and then plug it in here. You guys comfortable with that? Who asked that question? Is that good to get you going? Okay. Does you feel decent about that, or you rapidly taking notes? Huh?
Can you just do it really quick?
I could.
Make us feel better.
I really could. So why don't you guys take a minute? Try to finish that out. Give you a little hint if you're stuck. You can collaborate if you need to. You can.
No, second equation, sir, how did you make the second equation?
Oh, where did this come from in the first place? I know I have 88 feet of fencing, so I've got to fence this, and this as 4Y. Right, they're each Y.
And it's, second.
So Y plus Y plus Y plus Y plus 2X's. That's where my fencing has got to go, and I've only got 88 feet. I want to use all of it. All right. So if you do this, you get here. So eventually you get here. Is that cool? This is multiplying it out and getting everything on one side. Because of course when you have a y squared in your equation, you probably have to equal it to 0.
I'm not getting how the 80 is positive on the right, it comes over and stays positive.
Didn't come over. These actually went up. That's negative, now it's positive. That's positive, now it's negative. I'm trying to make my y squared positive.
Why you by 2?
Yeah, now I can divide by 2. Kick ass. I definitely want to divide by 2 if I can, because I hate when there's a number out here that's not 1.
Yeah.
So I'm going to force it to be 1. So divide by 2. And that one's not too bad, right? Are there factors of 40 that add maybe 22?
Can we use this equation as equation 2 and multiply it and then get either a value of x or y?
Yeah, once you solve this equation for, you'll get 2 values of y. You can plug it back in to get 2 values of x. Yeah.
Break the middle term? Break the middle term?
Yeah, now you just factor that. Yeah. So you can factor this directly. Yeah, 20 and 2 multiplied to be 40. If they're both negative, they add to be negative 22. So you get y could be 20 or y could be 2. So if y is 20, what's x going to be? Considering that x times y is 8. 4. If y is 2, x is 40. So here's the trade-off from what was happening earlier. They ask you how big should each plot be. So this one by itself should be 20. In this case, it would be 20 by 4 thirds, because this whole thing is 4 here, right? You with me?
Yeah.
So that's why at first I wanted to try to do this guy. But they really never say that they're all the same size, but I guess we're going to pretend like they aren't, so that no kids are upset. 20 by 4 thirds. In this case, it would be 2 by 40 thirds. Each one of these, each plot. You with me? That's why I had to cut it in 3. It's just 3 plots. And with rectangles, you very often get 2 possibilities, 2 different ways to set it up. Okay. Is that all right? Several of you look very dissatisfied. I don't know. Yeah, whatever. At the very least, you got a problem done, right? So any other questions from? Yeah. Well, what I did was, you distribute that y through, and then I added the 2y squared and subtracted the 4. Just to force my y squared to be positive. It doesn't matter. You could divide by -2, and then you end up at the same place. Yeah.
Number 46.
Oh. So this is one of those that people hate. But what form is it in? Cubes. And then I try desperately to come up with ways just to remember what the setup is. When I know it's a cubes, I can make a little dude, big dude. And the idea with cubes, squares is easy. Squares is cut them in half, put them in each, minus plus, you're done, right? Because you cut them in half and they each got the same thing. Cubes, you cut them in one piece and the other 2 pieces. One piece and the other 2 pieces. Okay. I'm getting a few people humoring me. I like it. So then here you get 2x, 2x, 2x. This is, y squared, y squared, y squared. So then you start building. What goes in the little dude?
2x.
1, 2x. Plus 1y squared. So the other 2x's go here. The other 2y squares go here. So all that hopefully should make sense. Mathematically, logically, if I want 3 at the end, if I've got 1 here, I better have the other 2 there so I get 3 in the end. The part that doesn't make immediate sense, but if you start multiplying this out, you get all this extra crap you don't want. So this can't possibly be the answer. Is this guy? That's the cleanup guy. What sign does he have to have?
Negative.
Negative, so you can kill all the other crap I don't want. Minus. And what always works? The product of these 2. Always only one negative in there. It's either there or it's there. And one last thing. You can never, ever, 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 ever factor the big dude. Unless there's a GCF you forgot. That big dude is never factorable. So don't waste time. The funky thing is, if this was doubled, it would be factorable every time. If this was double what it is, it would always be factorable. It isn't, it's never factorable. It's neat. Okay.
The cleanup was just the multiple of the first term?
Yeah, this guy is always the product of these two. Opposite sign.
Can we ask questions about the test homework that we have in everyone?
No, I'll check it first.
For 4E,
Is everybody cool with this here? Can I? Four E. All right. So if you did this problem, what do you have to do first? Factor. So you can see what it's made out of, see what denominator is missing something. So this guy factors like
X is 2x minus 2.
11. So now it's easy to see what the other dude's missing. So he's missing x minus 2. The hardest part about this problem really is normally that minus sign. Minus signs and zeros, they always find a way to screw us over. That minus sign has to apply to everything here. So you can multiply this out on the side and then just change all of its signs. Basically, that's the way you can always do it if there's a minus. You could also bring plus negative and put that in there and whatever, but to me it's just easier to just change all the signs at the end. So I would highly suggest do this, because now they're like denominators, I can slap them together. So far I get x squared minus stuff. So now I'm going to figure out what the stuff is. When you FOIL that out, what do you get? I like it. So now just change the sign. So it's minus x squared plus x plus 2. Is that cool? Okay, let me show you one little step. If I just put x squared minus exactly what I got there, because that's what that is, that negative would distribute and change all the signs. So the shortcut is just, if you see a minus in the middle, just do it and then change all the signs. Plop them in there. Not a big deal. For some reason, that always becomes a big deal. So now you just get those cancel. I get x plus 2 over x plus 2, x minus 2. Yeah, so that becomes 1 over x minus 2. Now, bear with me for just a second. Let me show you something that you guys don't normally get to see unless you take me for algebra. What is this? I like it. It's a fraction. And it's currently a fraction I don't know, but what can x be? Anything except?
0.
No, it could be 0. It can't make the bottom 0, so it could be anything except 2 or negative 2. Cool. All right, how are we doing so far? So, considering what I just said, x can be whatever the hell I want it to be, except for those things, because that would freak it out. I'm going to make x be, I don't care, 5. So, if x were 5, now I know I've got a couple people out there saying, where's this in the problem? So this is totally me doing an aside, showing you something interesting that you might have never seen before. You never have to do this ever if you don't want to. So if x were 5, this piece would be 25 over 21 minus, now this piece, remember, wasn't there. X is 5, so this is 6 over 7. I like it. So far, so good? All right. How do I subtract those?
Large common denominator.
So find the common denominator. Is that what you said? Sorry, I thought you said divide by. I was like, wait, what? So find the common denominator, and of course this guy just needs a 3. So you get 25 minus 18 over 21, which is 7 over 21, which is 1/3. x was 5, what do I get when I put a 5 in here? 1/3. All right? It's not, David Blaine. It's, that should not be a surprise, but it often kind of is. But if you think about it, that's why this is very difficult compared to that, because this is doing an infinite number of problems at once. So I would expect that to be kind of hard, right? That's just doing one specific problem. Any damn x you pick that will not make this guy undefined, that will happen, of course, because you just did all of them. So it shouldn't be a surprise. It should be, oh, Jeff, whatever. That should be your reaction, but it's still interesting to see that happen. So I like to show that to my Math 90 students and my Math 110 students because it's so abstract. I want them to realize that it's not really that abstract. It's a concrete problem, and I don't know what that x is. That's why it's harder than that, but it's the same thing. Okay. Yeah. Oh, and there were some. Go ahead. Oh, 4F. To hire a 4F was, the 4F was the complex fraction. I saw a few people doing this differently. You certainly could find the LCD for both the top and the bottom separately and then multiply by the reciprocal. That's beautiful. There's nothing wrong with that. A little more direct route is to just multiply top and bottom by each one's, by the LCD of everything. So if I had a Z there, the LCD would have to incorporate that Z into it. This is not too bad because they actually have the same LCD. It's nice compact, just XY. So if I multiply top and bottom by XY, which is completely legal, because I do have a top and a bottom. I can multiply top and bottom of a fraction by any damn thing I want to except 0. What's going to happen then? When I multiply this here, x cancels and it picks up another y. Is that cool? We go y squared. Here the y cancels, it picks up another x. Here the y cancels, it picks up an x. Here the x cancels, it picks up a y. And that one step made it go from holy crap fraction craziness to, okay. Now there is still one little thing that tripped people up on this. The top does not factor in such a way that it automatically cancels with this. You do have one little thing to adjust for. How does the top factor exactly? Careful. That's optimistic thinking. Yeah, the top factor is y minus x, y plus x. These look like they want to cancel when they do, but they can't because they're not exactly the same. So all you have to do that is take out of here -1. So that's the only reason they're not the same is because they have different signs. So if you take a -1 out, you get that, -y minus x. Bring the -1 in there. Yeah. Including it. Number 75 on the review. The 3x squared plus 4x. Okay. I'll give you a little insight into my thinking real quick. If I ever doing this and I'm taking a lot of questions and you have absolutely no questions, that's why I give you the homework for the entire semester, because now you can just sit there and get ahead on homework if you want to. Now, if you just want to sit back and absorb, that's cool too. That's not a bad idea. So 75 on 126.
break the middle term with 3 and 1, and then two same brackets.
And this one is a little evil. Yeah. Why do you have to? Well, let's not give up on this yet. So here's the steps you would take, and you're right. But let me show them why that has to happen. Now, the official kind of by-the-book procedure here would be 3 times -1. But I mean, notice 3 only has one way to factor it. 3 and 1. So the only way this could possibly work is 3x and 1. 1 is 1 and 1. You guys with me? It's the only way it could possibly work. And now, how do the signs have to be? Well, that's got to be -1, so they have to be different. But I get -x plus 3, oh shit. Or I get positive x minus 3. Oh shit. Felt like I was being watched. I realized I was cussing a lot, but it's not my dean, someone. So that I can't factor. So you always try factoring first, because quadratic will work, but it's relatively, computation intensive. Factoring should be the easy way to go. Unfortunately, we can't go the easy way because it won't factor. So quadratic formula. Yeah. Negative b plus or minus
4ac.
b squared minus 4ac over twice a. Have you ever suffered through a teacher showing you where that actually comes from?
Yes.
Yes.
It was
If you haven't, you will with me. I'll show you where it comes from. All right, and then you go ahead, let's see, -4 plus or minus 16 plus 12 over 6. Well, don't stop there. Can you just do this? Oh, yay. Of course not, because it's got to go into here also. So what can you do with root 28? I like it. So root 28 is 4 times 7. The square root of 4 is 2. Square root of 7, I don't know. And then you can divide everything by 2. And that's the last step. So it'd be negative. Somebody do me a favor, and I'm sure all of you guys have written this down, but keep track of this problem. When I'm going to do some stuff in the calculator later, I want to show you how to check this problem directly in your calculator. Using, you'll see. Yeah. The rectangular parcel of land. Yep. So a rectangular plot of land is 70 feet longer than it is wide. So right there, what would you call the width?
W.
I like it. And the width then would be, the length?
70 plus 70.
Yeah, width plus 70. The diagonal is, of course,
130.
the distance from where to where?
From the left to right.
From one corner to the opposite corner. I like it. So let's just draw one of those. So here's the diagonal. That would be 130 feet. We'll call this D for diagonal. You don't have to do that straight. You don't have to. You can just look at that directly and see where to go from there. I don't want to bring in more variables than I need. It's not really a variable. What shape does that make that you can then use to help figure this out? Triangle. In fact, a right triangle, which is awesome because then you can use old Greek tubes. Pythagorean theorem, cool. And that would say w squared plus a squared plus b squared. And for some reason, when I put it in the middle of a problem like this becomes w squared plus 4900, which of course is wrong. We just suddenly forget that, I don't care where the hell this is, you have to FOIL it. Don't lose the middle dude. That's when you get the funky answers. Like, well, Jeff, it's negative 11p1. Made out of black hole material. No, those scans are close. No, no, that means. All right. So now, I mean, this one's sort of like the first one we did, because plop it out, you get all these squares in there, so you have to try to factor what you get at the end. Not too horrible, like. Maybe. So what do you hear?
W squared.
And what's 130 squared?
1699.
Cool. Yeah, get everything on one side. Combine like terms.
It's 12. Take 2 off.
Divided 2 away. Right? The 0 will eat that up.
X plus 120.
Now hold on. Don't- Sorry. Let me show you something interesting. I'm hoping some of you guys either realize this or were taught this. Unfortunately, when people are taught this, it's hammered in your head that you find factors and then you check to see if they add. It's not a damn thing anywhere that says you have to find factors first. I could find things that add to be 70 first, which is a lot easier, and then check to see if they multiply by 6,000, and then it becomes sort of like a game when the price is right. If you're too low, you change things. If you're too high, you change.
Quadratic formula?
No.
No.
What do you always try before that?
How do we know, like, when do we have to use the quadratic?
If the factoring just won't work, then you go ahead and use quadratic. Technically, you could always use quadratic, but you desperately need factoring practice anyway. So try to see if this will factor. So what two numbers? They have to be different signs, right? So I'll kind of get us started. Like 130 would add to be 70 if like the 30 was negative. But what's 100 times 30? Not quite 6,000, right? So then you keep going. Yeah, if you try, what is it now? 120 and 50. Those are 70 apart. And 120 times 50 is 6,000. Cool. So that's, I keep trying to put the big one. So that's how you factor it then, using those two numbers. Has anybody ever seen that or kind of thought that out on their own? Or no? So when that number, and this was not that horribly difficult to factor really. Some of you guys might kind of happen on the 12 and 5 because the 60, 12 and 5 makes 7. But whenever that number gets difficult to factor, or the list of factors is huge and you just can't see it, you can certainly just start making that work first and then see if you can make the other thing work. They just both have to work. I don't care which one you make work first. Yes?
Is it wrong to use a quadratic formula?
No. But you need practice factoring. So if it's factorable, I'd rather see that happen. If you use quadratic formula, I can't say totally wrong. But if you're doing that one, everything I'll say, whoa, try some factoring somewhere. Yeah. So to finish this out, how would this happen?
W plus 120 and W minus.
So width could be negative 120, which hopefully, on my previous silly example, that's got to go away. So the width is 50, so what's the length? 120, which is interesting, right? Of course, the math doesn't care about negatives and all that kind of crap. So very often that one we throw out will be the other part of the answer. Not always, but sometimes. And was that the question? That's the question. I think it's just to find a... Which one is this? Okay. The dimensions, yeah. Yeah.
Could you do 9, the one just before it? On the
Sure. Is everybody cool with that? Okay. Oh, yeah. That's the one I expect the question on, is Mary driving around. You're like, just pay attention, Mary. What the hell? I mean, as a student, you see an algebra problem about some guy that put money into a bank and he forgot how much he put in there, but he knows that. Like, who are you with these thousands of dollars? And, oh yeah, I forgot how much. Bragging about your life like that? Yeah, I forgot how much. Yeah, exactly. At least he's rational about his wealth. All right. So 9, Mary. Mary drove from Amity to Belleville at a speed of 50 miles an hour. On the way back, she drove 60 miles an hour. The total trip took 4 2/5 hours. So the trip from A to B took a certain amount of hours, and the trip from B to A, and of course, which way took more time? Yeah, the trip from A to B, because you're going slower. Right? You're going the same distance. We're assuming she went the same route, which they should have said, but we'll go ahead and assume that's what they mean. So what kind of variables are hidden? I mean, they're a little hidden because they don't say a damn thing about them, but we know now that we need them. I like it. So let's actually call it like TA and TB. So starting at Amityville would be TA. Starting at whatever the hell the B one was is TB. So what's got to happen then? I mean, this distance between these two is...
R, and then R plus 10.
It's unknown.
Well, it is unknown. But it's the same, either way you go, right? So this is D. This is big. You don't even need that D, really. So what's got to be true about the distance I went from A to B, which is how much? How far did I go traveling like this? How far would this person go? Going 50 miles an hour for TA hours. How far would they go?
The same distance as...
No. I want an expression. I want nothing to do with this guy. How far would I go if I go 50 miles an hour for this long? What's the formula for distance and rate and time? E equals RT, dirt. So fill it in. What's the distance from A to B? It's 50 times the time. How we doing? So there's a couple, this problem is deceptively complex. I mean, or is it the other way? Deceptively simple. It sounds like they don't tell you enough, but there's these things that you realize, I need those. Oh, the distance is the same, and part of your brain goes, well, duh, and the other part says, well, I still need that. Because that's where the equation's going to come from. The distance I get using this is 50 t sub A. What's the distance I get using this?
60 TB.
60 t sub B.
T2B. TB.
TB, okay. So these two have to be equal. So I get one equation I get is 50 TA equals 60 TB. Now why do I know the way I just said that, I said one equation I get, why do I know I need another equation? Because I currently have how many unknowns?
T is unknown, and then B is unknown.
So right now I have 2 unknowns. Is that cool? You can see that? So the amount of unknowns I have must be matched by the amount of information I'm given. Distinct information. So you remember when they were kind of evil and they gave you a linear system of equations when one was really twice the other one? So you end up, the answer would be all points on the line or dependent system of equations. So they didn't really give you two pieces of information. It's sort of like I say, I'm twice as old as you are. And I'll tell you something else, you're half as old as I am. You know, like, you just say, it's not something else. It's the same idea. So what's the second equation I can write then, actually the simplest equation? Exactly. And I can use substitution.
We're going to be minusing that, right? The T-
Yeah, sure. If you want to, you can either solve for this TA and plug it in here, or you can solve this for TA or TB and plug it in there. Either way. They're both linear, so it really doesn't matter which way you go.
Are we going to have a lot of these DRT problems this year?
Not a ton, but enough.
I had so many in one time.
Oh yeah, I know. There will be a few, but they're not going to be that much. Yeah, because we got a lot of other stuff to do. No, that's as far as I can. No, I'm joking. So one thing I noticed, I can make 1 become 5 TA equals 6 TB. If you want to solve this one for TA, maybe, you get 4.4 minus TB. And now you plug that in there. And now you've only got TB in that equation, so you can solve. Sounds bad if your equation has TB, but we all know what we're talking about. So, let me tell you this. This is it's not a warning about this class, but it's a realization you have to make eventually, and you might as well start to make it now. This class is almost the first math class where you have to feel comfortable playing around. You have to play around with the math itself. You have to feel comfortable with, well, let me try, oh, that didn't work. Let me go back and try something else, especially when we get to trigonometry. So if you've ever had any pre-calc before, you're doing some trigonometry, you might know what the hell I'm talking about. You have to feel comfortable just playing around with the things you know. It might not work. Let it go. Erase. Turn the paper over, whatever, and start over. Right? Very often in the past, you've had to erase and stuff just because you made mistakes. This time, everything you do could be right. It's just not the way that's going to get you where you need to be, so you start over and try something else. That's what I call playing around with the math. This is probably the first math course where you really have to do that. Now some of you guys are like, great, Jeff. You'd have to tell me that. Okay. So any other, is that far enough for you guys?
Once we find the T2, can we put it into the distance and find the...
Well, once you find one, you just subtract it from 4.4 to find the other one. Because they have to add to be 4.4. Right? So if TA was 2, then TB has to be 2.4. Because they have to add to be 4.4. So hopefully TA is not 6. Because then you're going faster than infinitely fast. It's crazy. Back in time a little bit. Okay.
Honestly, could you complete that? I'm sorry.
These things happen. Let's see. So I got this, and I've got now, you could divide by 5 and solve for TA, but I find that most of the time students think to do this first, primarily, so it doesn't matter which way you go. So now all I have to do is plug this in there, because that's what TA is. So I can rewrite 1 as 5 times TA equals 16. So I've written this using that other distinct piece of information. So that's why you need 2 pieces of information if you have 2 unknowns, because I have to use one piece in the other piece. And now I've only got 1 variable in that equation I can solve. Right? By the way, if you don't like subscripts, there's not a damn reason you have to use them. You could call this time S and this time V. I don't care. Whatever makes sense. Now this shouldn't be horrible, right? 5 times 4.4 is 22. And then that's crazy nice. Actually, I kind of predicted that. I can't take credit for that. I was just happy. I was just lucky.
With 15, I had trouble finding the area for it.
Real quick, is everybody cool with that? You add that, you 11 divided, you get 2. So what's TA? 2.4. Cool. Okay.
The question was about distance.
Oh, really? Good. All right. So if you know TB is 2, what's the distance then if that's 2 hours? How far is it? 60 miles an hour for 2 hours is 120 miles. There you go. Cool. That's why it's a good idea, like I did earlier. Always go back to the problem and see what the hell, because normally you've done so much work, you're like, what the hell was the question? So I was about to answer somebody.
We're going to have the two distance, right? We're going to be taking distance of 60 miles and then the 30 miles and then add them together. That would be 220 miles. Just one distance good enough?
Yeah, they're just asking how far are these two apart. So it shouldn't matter which way. In fact, to check yourself, 50 times 2.4 is also 120. It's got to be the same distance. In fact, that's what set up one of our equations. Yeah. It's a good little check. Yeah.
Could we go over 82 on the loop all around this whole corner?
Well, 82 is another one? Oh, yeah.
I think I got the answer, but I'm not pretty positive I would have gotten it the other way.
Oh, yeah. So this is your classic, it was in the Far Side about the guy that goes to heaven. And they go to the gate and they say, we can't let you in here until you answer this question. A train leaves Wyoming. You're like, oh, shit, no. So Anthony leaves Kingstown at 2 p.m. and drives to Queensville, of course. His name should have been Jack, but 160 miles away.
That's 82, right?
82, yes. At 2:15, Helen. Oh yeah. Don't react too much, because I'm going to make a problem when the test has 3 people moving around. So get it careful. I won't do it. Helen leaves Queensville and drives to Kingstown at 40 miles an hour. So Anthony left Kingstown to go to Queensville. Helen leaves Queensville to go to Kingstown at 2:15, 15 minutes later. At what time do they crash pass each other on the road? Oh yeah, and this 160 miles is obviously just true, period.
If there's speed to it.
Does, hopefully it does. 45 and 40, yeah. That's what I find. So Helen left later, and it's going slower. So you don't really need visual. Here's Helen. If she left later and it's going slower, then they should obviously meet closer to Queensville. Okay. How are we doing so far? So a part of being able to do math problems like this, especially word problems, is summarizing the important stuff for yourself. The people that try to jump right into an equation, if you're able to, teach me. Okay? If there's a lot of stuff going on, you have to kind of try to summarize it somehow, maybe make some visuals. A lot of us are very visual. Okay. One way to do this problem is to make a little chart to organize this stuff. This might sound familiar from algebra. You don't have to do this. It's not a bad idea because I have Anthony and I have Helen. I have rate times time equals distance. It's not a bad way to do this. It's just an organizational method, really, to use this table. So if you don't like the table, don't do it. So I can fill, I know the rates directly, 45 for Anthony. Helen's got too many speeding tickets already. She's going 40. We know the distance between the towns is 160. How is that going to relate to our problem, though?
T1.
Yeah, exactly. Anthony's distance and Helen's distance have to add to be 160. Cool. You with me? Okay. So, it feels like there's two unknowns, and there really is, but there really isn't. I have a relationship between the distances. The true unknown here is the time each one of them went. So how long was Anthony going? And a valid answer in algebra could be x.
The time is given, right? The time is already given.
Yeah, the time you left, but how long has he been traveling? I don't know, so it's x. All right, cool. So it wasn't just an example. I was telling you the answer.
It'll be more clear.
Now, be careful about Helen. Exactly. What I'm about to say isn't the answer. What about Helen? The mistake most people make is the one I think I just heard. Helen's been on the road for more or less time? Less. So if he's been there x, and there's another little twist too.
X minus
X
five.
minus 15 quarter hours.
I love it. What units is everything in so far? Hours. Per hour is the hours. So I can't put x minus 15 because that's 15 hours. I have to put x minus 1/4 of an hour, 0.25 hours. Yeah.
Wait, I get this.
Which piece?
That's my info.
All right, so the way I've set everything up, the time is already kind of set up to have to be in hours. So therefore, the 15-minute difference, I have to represent that as a quarter of an hour. It's really easy to miss that. But it's just the thing you learn from chemistry. If you haven't taken chemistry, then you're going to learn it here. Check your units. They have to match, or else someone's going to freak out. That's where you get where they meet here. It's like, holy crap. So here, this has got to be Anthony's time. She's been less time on the road, so minus that quarter of an hour that she left later. Now, what's Anthony's distance then?
45x.
I love it. Just do what it says. 45x. 40x minus 10. I like it. A quarter of 40 is 10. And then what do those two things have to do? Add to be 160. So those d's aren't truly variables. They actually kind of come in to help me set up the relationship, set up the equation. So Anthony's distance plus Helen's distance has to equal the total distance between the towns, because they both start and then they both meet somewhere. So they cover together, they cover the entire distance between the towns. See, now, I always got to figure a way to say this so you don't feel bad if you're having a lot of trouble with this, but this is the kind of problem you should feel semi-comfortable just trying to attack. Even if, when I started this problem, I really had no idea necessarily where it was going to go. I knew how I was going to try to set it up. I didn't know that that was going to be the equation. I didn't know exactly what was going to be in here. That doesn't matter. What matters is what's the overriding idea. How am I going to try to start setting this up? You should feel comfortable starting to put something together. You don't have to know how something's going to end up, where you should be going. You just follow what they tell you and what the relationship is. You got to feel comfortable doing that. So, I mean, to finish that out, it's not too bad, right? But again, they make it nice numbers. Right, that goes in evenly, so X is 2. So 2 hours for Anthony, and 1 3/4 hours for Helen. And so what's the actual question?
What time?
What time do they meet? So if Anthony's been on the road for 2 hours, they meet at 4 o'clock. Just to check, Helen's been on the road for 1 3/4 hours, and that would still mean 4 o'clock. Yeah. No. Yeah, x plus x is just 2x. So exponents would be multiplication.
Where do you get the 40x minus 10? I get the 40x, where do you get the minus 10?
So right here, just multiply rate times time. So 40x minus 1/4 of 40 is 10. So I don't know if you guys remember from algebra, you have a problem where they both start in the same town, but one heads this way and the other heads that way. And then they say, how long until they're 300 miles apart? So then you would subtract the distances that they've gone, because the difference between their distances would be 300. Actually, I'm saying it backwards. That would still be an addition. It's when they're both going in the same direction that you would subtract the differences. So visual always helps. So in this case, if they're both going apart, how long until they're 300 miles apart? That's where you would add the distances. If they go in the same direction, how long until they're 10 miles apart? That's when you would subtract the two distances. So a quick little rough sketch of the situation really helps you think about what's going on. You don't actually have to get out in cars and go. All right. Anything else? Yeah. Sorry, I'm missing you.
70.
Oh, yeah, yeah. All right. I know I helped a few people out with this problem before. I don't think I did this one up on the board last time, did I? The idea is, whenever I'm factoring something, if I ask you to factor this, what would you do?
Add the powers.
Take
Oh,
x
no.
squared. Take x squared out.
All right. I'll let you erase that. So take the x squared out. Why did you take x squared? Why didn't you take x to the 5th out?
Then everything else.
This is not fair to this poor dude. So only a 2, right? So you always take out the smallest power. And of course, if you take out a positive power, all the other powers will go down because you're taking positive stuff away. So that will become 2 less, 2 less, and that's 2 less. He's just got nothing left. Poor little dude. So the same exact thing here. It's just 2 things. The lowest power is negative, and they're all fractions. But math doesn't care about that shit. It just says, okay, what do? Take the lowest power out. And what else comes out, of course? 3. So out comes a 3, and an x to the negative 1/2. If I take a positive power out and they all go down, when I take a negative power out, they all should go up. If you take negative away, it becomes more positive. Right? Minus a negative, or think about physics, or whatever the hell. Or not. Forgiving a debt? How's that? So if I take negative 1/2 out of here, this becomes 1/2 bigger, so now it's 4/2, which is x squared. 3, 1/2 bigger, so now it's a full x. Plus 2, and I took that dude away from it. And now the inside looks a lot better. Yeah. And again, I mean, things like this will happen to you very often in calculus, and that's why factoring is huge, and I will continue the whole